Hi. So this is attempt three of making this video. I managed to screw it up twice. Well, three times the charm. So we're going to talk about polymorphism. It's going to be two parts stitched together. One's going to be me at the whiteboard. The other one's going to be me at the computer. So I'm going to give you sort of the theoretical stuff on the whiteboard, and then I'll give you code examples and everything on the computer. So polymorphism starts off with this kind of thing. And this is going to be really important. Um, Probably about the first half of the course is spent at some level talking about this stuff. For some of you, this might be a review, but there will be things you'll learn along the way. For others, you will be learning it, and typically about a quarter to a third of people it's review, maybe a tenth. It depends on who I get. The By the time we're done the course, or halfway through the course, probably two-thirds of you understand it historically. And by the time the course is over, probably like 95% of you understand it. And hopefully, not too far after that, everyone understands it. Sometimes it just takes a little time to sink in. People absorb it at different times. People have that aha moment at different times. Um, but this here is really important, and this sort of sets the stage for how quizzes and the exam will go too, because I care about you understanding things, not just regurgitating things. So I'm going to ask you some questions while I go through this. When I ask you a question, you can pause, think of what your answer is, and then resume, and I'll give you the answer. So if you saw code like this, what kind of thing can A be? What kind of type can A be? So pause. So A can be an interface, it can be an abstract class, or it can be a concrete class. Those are the three possibilities. I guess it technically might be able to be an enumeration, but don't worry about that. C, what could it be? Pause. So C can be a concrete class or a final class. Now, you may not have heard of final classes before, and that's fine. The difference between a concrete class and a final class, concrete, you can create one, you can say new. A concrete class you can extend from, a final class you cannot. Generally speaking, that's an advanced design thing. There's two considerations. One is security, and the other one is speed. If a class is final, the virtual machine can make some optimizations. If you make it final, there's also some security thing which comes into your design. Both are beyond the scope of the course. String, for example, is final for both those reasons, which I'm not going to go into, but you can't extend from the string class. So there's an example. So if we were to draw this hierarchy, we'd have A up here and C down here. Since C has to extend or implement A can't be a final class, right? Because if A is final, C can't be a child of it. So that's important to know. So we know the hierarchy, we can draw the hierarchy, and we know what types A and C can be. What if we had something like this, though? So now we're going to call a method. And this is a really important line. This line demonstrates what we call polymorphism, and I'll talk about that more in a moment. What I'm interested right now is where can the method foo be declared? Now, there's two different words. There's declared and there's defined. Declared means it's made available. So it might be an abstract method at that point in time. And defined means it actually has a body with code in it. So it can run. So where does foo have to be declared? Pause. So foo has to be declared in the A type, and we'll see why momentarily, but it has to be. And where does it need to be defined? Pause. So based on this, C, it would have to be defined in C. We'll see that in a few moments. Okay? And the last question is, where could foo be defined? Pause. So it could be defined in A, or it could be defined in C, or it could be defined in both. Okay, so that's what you're gonna get out of this next little part here. Okay, so we don't know if it's true. That's a very poor question mark. So if we play the role of the compiler, what we're going to do is we're going to see, first off, we're trying to assign C to B. Let's make a little table here. So the type and the class, I guess we can call it, or the instance maybe. Declared and the instance. So if you have this, and you have this, your life becomes really simple, by the way. So I get used to drawing these things. Okay, so we have B. Yep, that's right. And then the variable. So we have B. And what is B declared to be? So look at, we're looking at what the compiler does. So B is declared to be an A in this case. Okay, that's the type, right? So B is of type A. Okay? And what is its instance? What did we create an instance of? Well, we created it as a C. Okay? So having this information makes our life really simple, especially when we combine it with this information. Okay? So I would encourage you to get in the habit of drawing these. Draw these. I just draw them in my head now, but your life becomes so much simpler. So when we say b.foo, where do we look for the foo method? Well, it's quite simple. We look at what the instance is. So we look in the C class for the foo method. If the foo method is there, we call it. If it's not there, we look at the parent. In this case, it's A. And we look for the foo method there. And assuming it has a body, we'll call that one. Right? If it's not there, we'll keep looking up. This ultimately extends from java.lang.object. So we'll go all the way up the hierarchy until we find the one that matches. That's polymorphism, because what's going to happen is it depends on what kind of thing we created here will dictate which method gets called. So if we forget about these abstract terms and we do this with something a little more tangible, if I had something like this, which is why I don't do this, because you can guess at it, because you all understand animals, presumably. If you consider B to be a cage, and that cage can hold animals, so you can put any animal in there. You can put an elephant, a giraffe, a shrew, doesn't matter. Weird magic box that can grow to the size to hold whatever put in it. So we're going to take that box and we're going to put a cat inside of it. They're going to blindfold our eyes. Remember, it's a box that holds animals. And we're going to pull that animal out of the box and we're going to tell it to speak. And it's going to make a noise. So in this case, what noise is it going to make? Pause. Right? It's a cat, so it's going to meow. If instead I'd made a dog and I did the same thing, I pulled the dog out of the box and I said speak, it would go woof, right? It's not until I actually hear it that I know what happened, right? So that's polymorphism. And it can be summed up as quite simply saying what speak method gets called depends on what kind of class we created when we instantiated B, right? We created a dog, so it's going to look in the dog class for the speak method and go woof. We created a cat, it's going to go to the cat class and do meow. So we have the ability to override, to change which method gets called based on which class we create an instance of. And we can go a step further with this. Back into abstract stuff. So looking at this, same questions. What can X be? Pause. Right? X can be an interface, an abstract class, a concrete class, or a final class. We don't know based on the code we're looking at here, right? If x is final, create x has to return an x. If x is abstract, it has to return or anything else, it has to return a subclass of x. So where does the foo method have to exist? Where does it have to be declared? Pause. We have no idea what any other class is here, so it becomes really easy. It's got to be x because there's no other class we can name. We don't know of any other classes. But because when we call foo on the b and the b is declared to be an x, um, that's where foo has to be. It has to be an x or higher above x, right? But it has to at least be an x. It can be higher up the hierarchy, but it can't be lower in the hierarchy. And we'll talk about that more when we get into the code later. If we look at create x, now what can x be? Well, it can be an interface, an abstract class, or a concrete class. Can't be a final class because our hierarchy looks like this. And now, where does foo get declared? No difference. Foo has to be up here. It has to be. It could be abstract. It could be a concrete method. It could also be a final method. What's a final method? Pause. So a final method is a method that you can't override. How do you override a method? Don't have to pause. You override a method by this class down here making one. Right? So you just have to override that, and again, we'll see that in the code. So the foo method must be declared up here. It can be defined either here or both. If we didn't have it up here, and we only had it down there, this code won't compile, right? Because what'll happen is the compiler will say, I want to call the foo method, and I want to call it on B, and B is declared to be an X, and X doesn't have access to a foo method. So it doesn't matter that we're returning a Y. The compiler here, right, looking at this stuff up here, has no idea Y exists. It knows nothing. All it knows is create X returns an X. So it could return an X. If it returns an X, there's no guarantee that X has a foo method, right? So again, we'll talk about this in code. We'll see examples of it. One other thing I'm going to do, I'm going to give you, not right now, but after the class this week, I'm going to give you a really big quiz. That's a take-home quiz. Normally, I would pretend it's worth marks if we're in person. Not going to do that. So the quiz takes about an hour, hour and a half. It gets progressively harder. So it's all about polymorphism. There's about 14, 15 questions. And as you go through it, it becomes increasingly more difficult. The idea is that you would do it on your own, just on paper, and then I would have you do it in pairs, and you'd hopefully get similar answers, but if not, you'd hopefully learn something. And then I'd say take it home and figure out what you did wrong. Um, and it's not worth any marks, so I tricked you. So everyone gets all stressed out because it's a really big quiz, but it's not worth anything. It's fine. So you take it home, you type it out, and you run it and compare your answers. And if you don't get the right answer from what you had before, one of two things happened. You typed it in wrong, or you got the wrong answer when you were trying to figure it out. The idea is that you'll stop and try to figure that out. And that becomes cumulative because each question generally builds on the previous kind of understanding. So if you got it wrong at one point, it's likely that you continue getting it wrong. The idea behind that is you take it home, you figure out why you got it wrong, you've learned. The next class we go through and I explain it to you if you've got any questions, and we explain those things. That takes a while. And then the class after that, we have the real quiz. And it's not an hour long. So expect that same sort of thing here. So this gives you the high level understanding from the theory point of view. Like I said, I'm going to make another video, stitch it together so that you've got the code point of view. And just like we're going to get the habit of, watch that before class. And then if you've got questions, ask away in class.
Okay, so I'm going to do some of what we were talking about in the theory portion. So we'll start off with, best as I can remember, something like this. First off, just stylistically, I never do this. I always do it like this. So I always have my, I guess we need a method. So a couple of things stylistically. I always make all my parameters final. I make as many of my variables final as possible as well. Final just means once it's been given a value, you can't, once you've assigned it something, you can't reassign it. So you'll see me do final a lot. So every parameter I pass in is always final. So A and C don't exist yet. And if I remember right, it was b.foo. So we're going to need to add new classes. Normally, I would make a new file for each class, but I want to show as much as I can on the screen here at once. So I'm actually going to break a few of my other rules. I line these up always too. So I want to be able to change things quickly for you. So interface A, and we'll make it interface B, C, which won't work, but that's okay. And an interface can extend another interface. So there we go, but we see this doesn't work because you can't say new on an interface. So we could try making an abstract class. And that also doesn't work because you can't say new on an abstract class. So we could try making it a class. That works. And we come back and try making it a final class. That also works. And this should be implements. So we can make this a final class or a class. Those are the two choices for C because we're saying new on it. If you're saying new, it has to be a class or a final class. When you're just declaring a variable, it can be an interface, it can be an abstract class, and it can be just a regular class, but it cannot be and it could be a final class. That'll work there, but this won't work because we can't extend from a final class. So those two work. So looking at just this line, this could be an interface, an abstract class, a concrete class, or a final class. Once we see that we're setting this to new C, that knocks final class off the list. And C, because we're saying new on it, has to be a class or a final class. We're missing foo, so let's go ahead and put foo down here. And you'll notice that that does not fix that issue. We need to put foo up here. And if we make this an interface, then this works, right? This code up here works. It's all happy because when we call b.foo, B is an A, and A has a foo method, so that's fine, right? If we don't have that, it's not happy because B doesn't have the foo method. This isn't happy though, because when we say we're going to implement an interface, it tells us that we have to override these methods. Right? And now everything's happy. I can actually run this and we'll see the output. There we go. Just show you that again, just to be sure. This quick. So we're printing out CFoo. So when we're reading the code, we come in here and we say, okay, we've got an A called B, and B is assigned a new C, and we're going to call the foo method. So the compiler, there's a two-step process. The compiler is going to look and say that, okay, B, we're calling b.foo. What is B declared to be? It's declared to be an A. So does A, or a parent of A, have the foo method? Yes, it does. We're all good here. Then at runtime, we're going to say b.foo, and it needs to know what is B. Well, B is actually a new C, So we're going to look at C and see if it has a foo method. If it does, we'll call it. Now, just to be sure, let's comment this one out. And this doesn't work anymore because the compiling side says, I need this thing to have a foo, and this thing is an A, and the A doesn't have a foo. So it doesn't matter. You and I can look at this and go, okay, this is assigned a new C. It doesn't matter that C has a foo, because what happens if we did this? So D implements A. It's no longer obligated. Just save some space. It's no longer obligated to have a foo method, right? D doesn't have to have a foo method. It's all good. We can assign this a new D. It's fine. But D doesn't have a foo method, so we can't call the foo method. So it's not happy. So we have to put it up in here. Now it's happy, but this one isn't happy because we no longer, sorry, I'm just trying to get everything to fit on the screen as much as possible. We no longer have an implementation for foo. So if we were able to call this foo method, what's it going to do? It's going to come down to D and it's going to say, I don't have a foo method. The only foo method I have is an abstract thing. I can't call it, so it doesn't work. So we have to provide an implementation. So if I run this now, it prints out dfoo. If I change this to a C, it prints out cfoo. So it depends, polymorphism, when it depends on did we make this a C or a D. Right? Now if we make this an abstract class, and make this an abstract method, and we extend it instead, and we extend this instead, there's not going to be any change. We can run it again. It'll print out cfoo again. We change this to D. It'll print out dfoo. No difference. But let's go ahead and make this not an abstract method anymore. Let's make it concrete. And let's go ahead and take this one here. Now, what is the output going to be? Is it going to be A or C or D when I run this code? So pause, think about it. Okay, so here's where students run into trouble to begin with. They look at this and go, okay, well, B, I'm calling B foo, and B is declared to be an A, so I'm going to look in the A class and it's got a foo and I'm going to call it. But it doesn't do that. It still calls the overridden one. Okay? So why does it do that? At runtime, remember, what happens is when we say b.foo, it looks and says, what is B pointing at? B is pointing at a C. So it goes to look at the C class and says, do you have a foo method? And if it does, it calls it. We don't have to provide this foo method. We can get rid of it. So now, if we call D, the runtime is going to look at it and say B is pointing at a D. We're calling foo. Does D have a foo method? Yes, it does. We're going to do that. If we change, so let's run that and see. Okay. And then the other one is when we call C. So b.foo, right? B is pointing at a C. So we look at the C class. We don't see a foo method. So now we go up to its parent. It extends A. So is there a foo method here? Yes, there is. So it should call that one. So let's see. Okay. So that is the first piece, right? Understand the second piece. Understanding that it's going to call the one depending on which one you do, C or D. That's something people grasp easily. Where people start to get tripped up is they say, well, no, this is declared to be an A, and I'm going to look in the A class, which totally negates everything that we just learned about. Well, it depends on if it's C or D, and I'm going to look in there. So every single time you call a method on B, it's right now going to look at the C class first for it. If it doesn't find it, it'll look at A. If it doesn't find it there, it'll look at object, because this implicitly extends java.lang.object. Okay. So let's do one more change to this, that create method. So we'll call it create A instead of create X like we had. So if we get rid of this, we don't look at it, all we know is that create A has to return an A, right? Which means it has to return an A or a subclass of A, right? So C and D are both subclasses of A. A is abstract, so we can't return that. So it has to be either C or D for this code. So all we know is that it's returning something that is an A. And then we're going to call the foo method. So that should drive the message home that no, A has to have a foo method because this thing returns an A. So, the only type we know of for sure is A. So A has to have foo, or something higher than A has to have foo. So let's go ahead and change this up a little bit. So this is another thing. We'll talk about it later on in the course, but this is another thing. This static initializer lets me initialize things once for the class. So this is going to return true or false. Now I'm going to show you something I really don't like. A couple of things I really don't like. First off, since we're no longer saving space, I prefer to do these on their own lines. It's easy to add them up or line them up visually. This is something that students do a horrible job of, in my opinion, and it carries over to real, not that you're not real developers, but professional developers too. Once you've returned, you don't need the else, right? It's done. So we can get rid of the else. Doesn't matter. Okay, that's the first thing. So if you find yourself doing if return and else return, don't do that. Just if return and then whatever. Once you've returned, there's nothing else to consider, so the else makes no point. But also, I like to only have one return per method. So I can't do that. So I need to make a variable, final A. So that's what I prefer to see. One return, do your if else, all that kind of stuff. So we're just going to return randomly a true or false, which means we're randomly going to return C or D, which means this code here, I can't tell you what it's going to output. It'll print out either a foo. Well, actually, we'll go ahead and override the method again. It'll either print out C foo or D foo. But I can't tell you what it's going to print out because it's random. So we'll run it a few times and see what it does. So there's C foo. There's C foo. C foo. There's D foo. It's like flipping a coin, right? So if you flip a coin, right, eventually over time it's gonna get to 50-50 sort of thing or close to it. But we don't know at any given flip of the coin what it's going to be. So we truly don't know what the output of this program is. We know what the possible outputs of the program are. This is either going to print out C foo or D foo depending on if create returns a C or a D, which is a random thing. We don't know. Okay. And now there's no possibility of it printing out a foo because what happens is when we call the foo method, It's going to look at A and say, do you have a foo method? Yes, I do, because all A's have foo. Then it's going to say, okay, well, were you a C or a D? And depending on if it was a C or a D, it'll print out the appropriate one of these two. But we can't know that in advance because it's random. Okay, so no possibility of us knowing what the output's going to be. So there's not much going on in this code. It's all pretty simple, but it's super important and it contains all the elements we need. So I'm just going to recap one more time. And pay careful attention when you're doing the big quiz. That's not a real quiz; it's fake. But pay careful attention because all these same rules apply. And remember the way I drew the diagram. If you draw the diagram, your life will become easier. So the compiler says, okay, we've got B, which is declared to be an A. So create A has to return some form of A, so an A or a subclass of A. And then we're going to call the foo method on it. That means that A has to have the foo method, otherwise the compiler will not be happy. At runtime, though, when we go to call the foo method, it needs to know exactly what was created. Was it an A, a B, a C, a D, an E, F, G, whatever it is, right? So in this case, was it a C or a D? When we know if it's a C or a D, and we don't necessarily know at compile time, it might happen at runtime, could be based on what a user enters, could be based on any number of things. Could literally be based on the phase of the moon if you write your code that way. So based on which one of the subclasses got returned, it will depend on what foo does. Right? When you're depending, it depends on, it means it's polymorphism. So if create A returned to C, we're going to look in the C class to see if there's a foo method. If there is, we'll call it. If there isn't, we'll call the one in A. Right? There's one in A, but if it's a D, it'll call the one in D. Right? So if it looks in C, it'll say, do you have a foo method? No, I don't. Go look at my parent, look at who I extend, right? And it'll look for there and say, do you have a foo method? Yes, I do. Okay, I'll call that one. It isn't actually implemented that way. That would be far too slow. But if you go through that process, it's really hard to get the answer wrong. So this is the kernel. This is the basics. This is a really important thing. This one line here is super important. What method gets called depends on what we created. And then every method we call on this thing is going to go through that same process of always looking at what did we say new on. It does not matter that it was declared to be an A. It matters that it was assigned to C or assigned to D. What it's assigned matters, right? When we're trying to tell what the output is. When we want to know if things will compile, then we need to know the structure and all that. But for once it's compiled and running, all we need to know is, did we create a C or a D? Does that class have the foo method or not? If it doesn't, what's the parent class? Does that have the foo method? If not, keep going up and up and up until you find it. Okay. That's enough. There's a couple other things we can do in class, but we'll see where the questions go.